already see some companies, this is just one simple example, of a company in the United States that has started to look at people's stools and do essentially metagenomic analysis. Now, it's not the same research-grade metagenomic analysis. It's a more simple, let's look at the 16S RNA. But what these people are finding is they have huge number of referrals from all sorts of doctors who have patients who have chronic diseases like colitis, and for which currently the health care system, at least in the US, is incapable of dealing with because it's a system that has a model of dealing with acute diseases, not with chronic diseases. So we have no idea really what to do about chronic diseases. And I think that this kind of approach is increasing. This is an example of a report of theirs, and even though you probably can't read it, these are big bacterial taxa and their prevalence in this person's stool and what that means in relation to all the other stools that they've looked at. There are lots of issues still with this. It's mostly to illustrate that this is coming. And so on the metagenomics, basically, the folks at Argonne built MGRAST, and it handles, so it's the analysis and database and all that. And our focus in Patrick is going to be what's the relationship of this data to surveillance, reservoir detection, and horizontal gene transfer. These are the three first questions that we want to use these capabilities to portray data in Patrick. And Rick Stevens and I at Argonne, who's one of my key collaborators there, did a very preliminary analysis of, at the time, all the metagenomic samples in MGRAST. And what we found, these are the taxa of interest to Patrick. This is mandated by the NIH. It's not our decision. Is that based on